All right, so for homework over the weekend, I gave you a right triangle, and I asked you to find the 6 trig functions based on that triangle. All right, so the triangle I gave you, we had our angle here in the lower left corner, and we had both the legs, the 2 and the 3. Now, like we dealt with last week, all right, I would recommend labeling your sides. Again, remember, some of your sides depend on where your angle is. All right, so the first side is always the same, and that is the hypotenuse. All right, so that's what, here we don't know that, so we'll have to calculate that before we start doing any of our trig functions. Now, with reference to our angle down here, we have our opposite side would be the 3. Okay, because it is not touching our angle. And then the 2, by process of elimination, we could say is our adjacent. All right, so again, before I can find that, any of these, most of these, we have to find that third side. All right, so the hypotenuse is always our C in Pythagorean theorem. So we have a squared plus b squared equals c squared. So plugging in what we know, 2 squared plus 3 squared equals c squared. Okay, we get c, or our hypotenuse, h, however, whatever name you want to call it, is the square root of 13. Okay, and like we said last week, we're going to keep it like that. I don't want to know the decimal. It's easier for us to keep it as a square root. All right, so now we can go through our trig functions and solve them, even though we don't know what our angle is, right? As long as we have the sides of our triangle, okay, we can calculate the trig functions. So sine, we know, we said, is the opposite over the hypotenuse. Right, so my opposite is 3 over my hypotenuse, which is the square root of 13. If you gave me this, or if you calculated this and gave me a decimal, you would be technically correct. But remember, we don't like the square root in the denominator. So if we write it in proper fraction form, it would be 3 times the square root of 13 over 13. All right, remember, we multiply numerator and denominator by what your current denominator is. That removes the square root down there, and it puts it in the numerator. For cosine, it is adjacent over hypotenuse. So similar situation, but in our numerator, we have a 2 now. So the cosine is 2 over the square root of 13, or 2 times the square root of 13 over 13. Tangent is a little simpler. It is opposite over adjacent. 3/2, or 1.5. All right, nothing fancy there. We can leave it just like that. Now the cosecant, remember, is the reciprocal of sine. So you could go ahead and you could take the reciprocal of this, but then you'd have to mess around with it because the square root would be in the denominator again. So for that, we're going to go to the improper form, and I'm just going to flip this. And it's just going to be the square root of 13 over 3. Similar for secant, we're going to flip the original there. So now I'm going to have the square root of 13 over 2. And cotangent, we flip tangent, and that is 2/3. Any question? Okay, so before we move on, I do want to show you this. Let me see if I can do this right. So it's upside down. So let me flip it. Hey, look at that. Okay. So here we have a list of our sines, cosines, and tangents of our special angles. So we've seen these numbers before from our unit circle, right? All of these values pop up going around our unit circle. So this is just a quick reference. You know, who knows, by the end of the year pre-calculus, you may have these memorized. I'm not asking you to memorize them, though. It would be helpful if you did, though. All right. But you can look this up online, or you can, you know, take a quick screenshot or reference today's video at any time. All right, and these will be there. All right, so these are 30, 45, and 60 degrees are our three most common angles. Their respective radians, right? 30 is pi over 6, 45 is pi over 4, 60 is pi over 3, and sine, cosine, and tangent of all those. All right, so you guys can use this as a reference for those special triangles. Okay, so let's So today we're going to go over a list of some rules that we have. Oh, I got to flip this back. And these are called trigonometric identities, or just trig identities. So this is a list of rules that we can use to kind of simplify things for ourselves. Yeah, let me just get started. All right, so the first group is called reciprocal identities, and I'm not sure how well you're familiar with them, but I have talked about these as we go on, as we've been doing our lessons. But this is just a formal representation. So the three not common trig terms cosecant, secant, and cotangent, I've referenced them as reciprocals because the cosecant is equal to 1 over sine. Secant is 1 over cosine, and cotangent is 1 over tangent. All right, they're called reciprocal identities because they match with reciprocals. Right? And we can say the reverse. I can say that the sine of an angle is equal to 1 over the cosecant of that angle. The cosine of an angle is equal to 1 over secant. And tangent is 1 over cotangent. Now, most of the time that we're going to be using them, this top row here. Okay, I see a cosecant. I don't like dealing with cosecants. There's no cosecant button on the calculator. So I'm going to change that to 1 over sine. Oh, excuse me. All right. So this is the more familiar side that we're going to, but we can also flip it. Next, we have what are called quotient identities. Now, the first you should be familiar with. And that is that the tangent is equal to sine over cosine. All right, so this is a quotient, hence the name quotient identities. Now, this is where trig identities really comes into play. We can combine some of our identities to manipulate our functions, right? So I know that cotangent is the reciprocal of tangent. So if I wanted to write cotangent as a quotient identity, I would flip that, and I would have that the cotangent is equal to cosine over sine. You could even take this further. I'm not going to because they're not true identities, but I can say that the tangent is equal to sine times secant, because 1 over cosine is secant. Okay, I can say that cotangent is cosine times cosecant. Right, and that's what we're going to be doing. We're going to be manipulating our functions to make it easier to read for us. Now, these last three. They come from a few different things. They come from the unit circle, and they come from triangles. Okay, that is why they're called Pythagorean identities. Now, this first one you may be familiar with. But we have a rule that the sine squared of an angle plus the cosine squared of the same angle is 1. Sine squared plus cosine squared equals 1. So you may have seen that in geometry, I'm not sure. We do have two others. Again, we manipulate the sine squared and cosine squared with some of our identities here. So we also have one plus tangent squared equals secant squared. And we also have 1 plus cotangent squared equals cosecant squared. Now, there are quite a number of more trig identities, and we'll be coming across them as we advance in trigonometry. But these are the basic ones, all right? So please have this somewhere to reference, okay, whether it's in your notes, or again, if you take a screenshot and you have it saved. Okay, we will be referencing these very frequently as we continue to talk about trigonometry. All right, we'll be adding to this list, but these are the basics. Any questions so far? What time is it? Okay, we still got time. All right, so one of the ways we use our trig identities is to help us solve for certain trig functions without the use of a triangle. So here we're given a scenario: let theta be an acute angle such that the tangent of theta is 1/3. Now we want to find cotangent and secant. Now, one thing you can do, going back to geometry, again, I'm not sure how this was covered or what exactly you covered, But you can create a scenario. You can make your own triangle, right? I can put theta there. And it tells me that the tangent of that theta is 1 over 3. So remember, the tangent gives us the proportion of the opposite over the adjacent. So this isn't drawn to scale, but my sides would be 1 and 3. I can then go ahead and I can find the hypotenuse, and I can answer all my questions. But now that we have these rules, these identities, we can do things a little quicker. So the first one we want to find is cotangent, right? So we know that cotangent is the reciprocal of tangent. So I just flip my answer, the numerator and denominator. So cotangent, I'm just going to write it out formally. You don't have to do this as long as you start to feel comfortable. So cotangent is 1 over tangent. Well, we know that tangent is 1/3. So we have 1 over 1/3, which gets us 3. Okay, or you just know that you flip them around. That one is pretty straightforward. Now the second one, secant. Okay, that one can pose some problems, right? We know secant is the opposite of cosine. Well, I don't know anything about cosine here. All right, well, let's see if secant pops anywhere else. Okay, well, here's secant. And secant here depends on tangent. Well, we know what tangent is. Now, I'm not sure if I mentioned this before, but let me just add a side note. Saying a trig function squared of an angle is saying the same thing as that squared. All right, so when you see a trig function with a square next to it, you can move it on the outside like this, but it's neater and it's quicker for mathematicians to write it like this. All right, so if you had sine squared of, let me not do 90, do 45, that would be the same thing as the sine of 45, taking that answer and squaring it. Okay, so just know that as we go forward. So again, we have tangent and secant, right? Tangent and secant I see here, so let me set up 1 plus tangent squared, so that's going to be 1/3 squared, equals secant squared. Right, so now we just go through basic algebra. We know, look at that. Okay, yeah. So this here is going to give me 1/9. Okay, 1 plus 1/9 is going to give me 10/9. So I have 10/9 equals secant squared. I want to know what secant is, so to get rid of that squared, we're going to take the square root. Now here, we took the square root. We don't need that. Anytime we have a square root and a fraction, we can split it up between the numerator and the denominator. So the square root of 10, well, that's just going to stay the square root of 10 because we can't do anything. Over the square root of 9, well, the square root of 9 is 3. So we have that the secant of our angle is the square root of 10 over 3. And that would be our final answer. Any questions there? All right, so another situation where you might see trig identities, and we'll be taking a look at this stuff later on in the year when we know more rules. Is they're going to ask us to prove certain equations. So they want us, for example, here, this will be the last thing we do today. We want to prove that the sine times cosecant of any angle is 1. So here we're going to use our trig identities to replace and then hopefully simplify. So my rule with this, anytime we have, and you'll usually see something like, prove, or, they want you to get the left side to equal the right side. So one of the things you're going to do is you're going to keep one of the sides the same. I'm going to keep this side the same because that's real simple, right? If I try to make a 1 look like sine and cosecant, that might be trouble. But I can mess around with the sine and the cosecant and hopefully get me that 1. All right, so my general rule for this is our two most basic functions are sine and cosine. You can't break those down any further. So get everything into terms of sine and cosine and then manipulate further. So this sine is going to stay sine. And we know the reciprocal rule, that cosecant, I can replace it with 1 over sine. So if I multiply these, I get sine over sine, and they eliminate each other, and we get 1 equals 1. Right? So that's what we're looking for. All right. I'll show you a couple more examples with this tomorrow. Yeah, and then we'll continue with what they call solving the triangle, which is not too difficult. It's pretty straightforward. All right, guys. Any questions?